Yeah, so today we'll move on to the next three topics, which are fractions, algebra, and measurement. So that's like area and perimeter. So today we'll mostly cover fractions, and maybe if we have enough time, we can discuss a little bit of algebra. So, of course, here are the learning targets. So I know I asked you all last class if you are familiar with fractions, and you all said yes. So today's lesson hopefully is a little bit of a refresher, and maybe you'll be able to understand it a little easier. So the first learning target, by the end of this lesson, we'll be able to identify fractions as parts of a whole and decimals as another way to write parts. So another way to write fractions. Second is converting between simple fractions and decimals. Number three is understanding variables, constants, and algebraic expressions. So this will be the intro to algebra. The fourth goal is evaluate simple algebraic expressions by substituting values. And five is finding perimeter and area of simple composite figures such as rectangles, squares, and triangles, and more. So this is the measurement part of the lesson. So, okay. So we'll start off with this simple concept of fractions themselves. So fractions are what we call parts of a whole. So a fraction is a mathematical way to express a part of a whole. So if we have a whole shape and we want to just represent a part of it, that's what we can do with a fraction. So there's two parts to the fraction. You have the numerator and you have the denominator. So the denominator tells us how many equal parts make the whole. And the numerator tells us how many parts we have selected. So how many parts out of the whole do we have? So for example, you can see in this example, so we have 5 boxes, right? So we have 5 equal parts. So this is one equal part. All of these are equal parts of this rectangle. So 5 will be our denominator, right? Because we have 5 equal parts, and 5 equal parts make up the whole shape, right? And then, as you can see, we have only 3 of the boxes selected. So that will be our numerator because we have 3 selected parts. So we can represent this situation with the numerator on top and the denominator on the bottom, as you can see here as for example. So we have the numerator, and then under we'll have a line, and then we'll have the denominator. So this box here is represented as 3 over 5. So we have 3 boxes selected, and we have 5 boxes total. And one thing to note is that fractions always have to use equal size parts. So this is a good example because we have five equal parts, but we cannot have, for example, a shape like this. See, all these different parts are different sized. So we cannot use this to represent a fraction. So does everyone understand fractions so far? Good. So now that we understand fractions, we'll learn about the different types of fractions. So there are three main types of fractions. So there's a proper fraction, there's improper fractions, and there are what we call mixed numbers. So, so these are our three types of fractions. So the first fraction we will discuss is the traditional fraction, and that's what we call the proper fraction. So this is a fraction where the numerator, remember numerator is the top, is smaller than the denominator, which again is the bottom. So some examples are 3 over 5. You see here, 3 is less than 5, so 3 is smaller than 5. There's 7 over 10, same thing. 7 is less than 10, so the numerator is smaller than the denominator. You can have any examples, so 2 over 7, 3 over 11, 5 over 13, 7 over 9, and the list goes on, right? So what we can understand from proper fractions is that we use them to represent a smaller part of a larger whole. Remember, the denominator is the whole that we're looking at, and the numerator is only the parts that we're selecting. So it's a smaller part of a larger whole. So does that make sense to everyone so far? Is everyone understanding so far? Okay, so the second type of fraction is the improper fraction. So this is the opposite of the proper fraction. So remember, in the proper fraction, the numerator was smaller than the denominator. However, in improper fractions, the numerator is greater than or equal to the denominator. So here are some examples. We have 5 over 5. 5 is equal to 5, so that's good. We have 9 over 4. 9 is the numerator, and it's greater than 4, so that is good. So other examples could be 11 over 7, 6 over 5, 20 over 17, and so on. So all of these have a numerator that is greater than or equal to the denominator. So this is why we call it improper, because we use it to represent a larger part of a smaller whole. However, logically, that doesn't make sense, right? If we have a shape, how can we have a part that is bigger than the shape, right? We can usually have only a smaller part of the shape. So that's why we call it improper fraction. So is everyone understanding improper fractions?
Yes.
Okay, good. So the last one that we have to discuss is mixed numbers. So a mixed number is a whole number and a fraction. So remember whole numbers, we discussed it a few classes ago. Whole numbers are 0, 1, 2, 3, 4, so on, right? So some examples are 2, 2 and 1/3. That's one example. 4 and 5/6. You have 7 and 6/8. You can have 11 and 3/12. So all of these are examples of mixed numbers, right? So let's see, how do we get from an improper fraction to a mixed number? So let's take one improper fraction. For example, we'll take 11/6. So we want to write this one as a mixed number. So we'll have to see, so the numerator is bigger than the denominator, right? 11 is greater than 6. So we want to see how many times does the denominator go into the numerator. So how many times does 6 go into 11? How many times? One time, two times? Does anyone know?
Can you explain again that?
So how many times does 6 go into 11? Okay, so let me try a bit of a simpler example. So let's try 5/3. So we see the numerator is bigger than the denominator, and we want to write this as a mixed number. So a mixed number, we need one whole number and we need a fraction. So where do we get our whole number from? So the way that we find the whole number for the mixed number is we see how many times does the denominator go into the numerator. So here, for example, 3 goes into 5 only one time, because if you have 3 go in twice, you'll get 6, but 6 is bigger than 5. So we can have 3 go into 5 only once, and you'll have a remainder of 2. Does that make sense? So because 3 can go into 5 only once, this will be our whole number, and the remainder will be the numerator of our fraction part. So therefore, 5/3 can be written as 1 and 2/3. So that is our mixed number for 5/3. So we'll try one more example to make sure you have understood. So let's try 17 over 8. So the first thing we want to do is find the whole number portion of our mixed number. So can anyone tell me what we would use for the whole number?
2 1/8. 2 1/8.
Correct. So our mixed number would be 2 and 1 by 8, right? Because 8 goes into 17 twice, and what is left afterwards is 1, and that will be our numerator. So that's how we can write improper fractions as mixed numbers. So, so the next concept is what we call equivalent fractions. So equivalent fractions. So can anyone, did someone have a question?
Explain again.
Okay, so you want me to explain one more time the mixed numbers?
Yeah, let's take it.
Okay, so I'll explain this one more time, how we can go from an improper fraction to a mixed number. So one example here. So we'll do another one. So let's take 13 over 4. Okay. So we want to write this improper fraction as a mixed number. Sorry. Okay. So 13 over 4 was the example, right? So we want to write this improper fraction as a mixed number. So to find the whole number portion of the mixed number, we have to see how many times the denominator goes into the numerator as a whole number. So,
One 3/4. Is it correct?
okay, so everyone is understanding so far?
3 1/4.
Okay, so 3 1 by 4 is correct, but I'll just show how we get to there. So 4 goes into 13 three times, right? So 4 times 3 is 12. So it goes in 3 times with a remainder of 1, right? 13 minus 12 is 1. So this number will be the numerator. So our mixed number will be the whole number part, so 3, our numerator, and then the original denominator. So our final answer as a mixed number is 3 and 1 by 4. So does that make sense for everybody? So everyone is understanding, or should I give another example? Okay, good. So you, explain it. Should I explain it again? Sorry, I'm not able to understand. So do you want me to explain it one more time, or we can move on to the next concept? So con continue. Okay. So the next concept we have is equivalent fractions. So can someone tell me what does equivalent mean? Sorry, what was that? Equivalent is what? Same. Correct. So equivalent is equal, which is same. So this means same fractions. So this is how we can show the same amount with different fractions. So essentially, multiplying or dividing the numerator and denominator by the same number gives us an equivalent fraction. So even though we're multiplying the numerator and the denominator, the value of the fraction stays the same. And equivalent fractions help us compare and simplify. So is everyone understanding that? And we'll go through some examples now. So let's go through an example of finding equivalent fractions. So we'll take any fraction, let's say 4/7. So 4/7. We want to find an equivalent fraction to this. So remember, to find equivalent fractions, we have to multiply or divide both the numerator and the denominator by the same number. So we'll take any number. Let's say we want to multiply by 3. So we have to multiply both the top and bottom, the numerator and the denominator, by 3. And what do we get? 4 times 3 is 12. 7 times 3 is 21, correct. So we've multiplied both the numerator and the denominator by 3, and we have this fraction. So even though the fraction looks very different, they are the exact same. So 4/7 is equal to 12/21. And these are equivalent fractions. So another example, let's take 18/21. So here we can divide both the top and bottom by 3, for example. So remember, we can either multiply or divide. So here we'll divide by 3 and we'll get 6 by 7. So we have now found an equivalent fraction for 18 by 21. So this is how we find equivalent fractions. And in the next example, we'll see why these fractions are equivalent. So this is what we call simplifying fractions. So simplifying fractions is how we get from a very complex looking fraction to a simple one, but it has the same principle in equivalent fractions. So essentially, we want to find an equivalent fraction in the simplest form. So, for example, we can take this fraction, right? So at first, this fraction looks very, very complicated. However, if we can find an equivalent fraction that is simpler, that's what we want to do. So what we do here is find a number that divides the numerator and denominator equally. Remember, equally means result is a whole number, right? And if we can find another number afterwards, we can get an even simpler fraction. So the goal is to find the largest number that divides both the numerator and denominator equally. So there's a term for this, which we've learned already. Does anyone know what this is called?
33?
No, what do we call the largest number that divides two numbers equally? What is that called?
Equivalent fraction.
No, so just forget fractions for now. Just think of two numbers. So just think of 99 and 121. So again, the goal of simplifying fractions is finding the largest number that divides both the numerator and the denominator equally. So just forget fractions for now. What is this number called? We've already learned it in the past few classes. What do we call the largest number that divides two other numbers equally?
11.
No. I'm not looking, I don't want to know the number right now. I want to know what is this called?
Equivalent fraction. Equivalent fraction.
No, okay, so I'll give one more try. So just forget fractions, don't think of fractions right now. Just think of pure numbers. So what is the largest number that divides two numbers equally called? So it's called the highest
Common
common,
and fractions.
right? So essentially, all we need to do when simplifying fractions is find the highest common factor of the numerator and denominator. So we'll do this example. We have 99 over 121. So can anyone tell me what is the highest common factor of these two numbers?
121.
No, so what is the highest common factor of 99 and 121? I think someone said it earlier, but the highest common factor is 11, right? 99 divided by 11 is 9, so that's a whole number. 121 divided by 11 is 11. So now we can simplify the fraction pretty easily. All we need to do is divide the numerator and the denominator by the HCF. And we already did that, so we have 99 divided by 11 over 121 divided by 11, and that equals 9 by 11. So that is our fully simplified fraction. So it's a simple process. Just remember, all you need to do is find the HCF and then divide both by the HCF. So that's all we need to do when simplifying fractions. So everyone has understood this? Okay, good. So this maybe is the last concept we'll cover today for today's class. So this is what we call comparing fractions. So how do we compare the value of two fractions? So the first way that we can do this is through the common denominator. So common denominator just means the same denominator. So if we have two fractions, for example, 2 over 7 and 4 over 7, the denominators are the same. So this is a common denominator, right? So we can only compare the value of two fractions if they have the same denominator. So if we have a common denominator, only then are we able to compare two fractions. So for example, what we're trying to do here is we have two fractions. We have 2 by 3 and we have 3 by 4. So we want to see, is 2 by 3 greater than 3 by 4? Is 2 by 3 less than 3 by 4? Or is 2 by 3 equal to 3 by 4? Well, we won't know until we find the common denominator. And in order to do this, so before we find the common denominator, we have to use the concept we learned earlier, which is LCM. So it's least common multiple, remember? And once the denominators are the same, you can directly compare the numerators, and you'll be able to see which fraction is larger or which fraction is smaller. So does everyone understand this concept so far? We'll see some examples. So sh- you want me to explain one more time? Okay. So when we want to compare fractions, so if we want to see if one fraction is bigger than the other fraction, or if one fraction is smaller than another fraction, we have to use something called common denominators. And what this means is that we cannot compare two fractions unless they have the same denominator. So, in order to find the same denominator under a fraction, remember this is where we find equivalent fractions. We need to find equivalent fractions of 2 by 3 and equivalent fractions of 3 by 4 such that the denominators are the same. So, the way that we do this, the way that we find common denominators is by using the least common multiple. So LCM. Remember, this is what we learned just a few couple classes ago. And once we have the common denominator, we can just compare the numerators and we'll see which fraction is bigger or which one is smaller. So does everyone understand this concept now? Good. So here is what we'll do. We'll see an example now. So we want to see, is 2 by 3 bigger or is 3 by 4 bigger? Which is a larger fraction, right? So we have to see first before, like in order to find this, we have to find the least common multiple of the denominators. So find the least common multiple of the denominators, right? Because we want the denominators to be the same. So can someone tell me what is the LCM of 3 and 4? So what is the least common multiple? So remember, so two is not the correct answer. So remember how we find the least common multiple is we try different numbers. So we start with 1, 2, 3, 4, and so on to find which numbers are in common. So the least common multiple of 3 and 4 is 12, right? Because 3 can be multiplied to 12 and so can 4. So once we find the least common multiple, we want to multiply both the numerator and denominator by the LCM. So we do 2 by 3 and 3 by 4. So this is wrong, sorry. So we have to multiply both the numerator and the denominator by the same number, right? Because we want to find an equivalent fraction. So how we do this is by taking the first fraction, so we take 2 by 3, and we want the denominator to be 12, right? We want the denominator to be 12 because that is our least common multiple. So what times 3 gives us 12? So what number times 3 will give us 12? So it's 4, right? 3 times 4 gives us 12. So is is it time to go? I'm not able to understand through the computer. Okay, so we'll stop the class for today, um, and we'll continue with comparing fractions for the next class. And if you have any doubts, then you can watch the video that I'll upload to the YouTube page, and you can watch any doubts there. Right. Thank you.